Hello, kids. Today we are going to be learning how to solve literal equations. So, the example that we have here, ax plus by equals c, is considered a literal equation because there is more than one variable. So what we're going to do is when it says solve for x, it doesn't necessarily mean solve for x. What it more means is isolate x, because we can't actually solve for the value of x since there are multiple variables. So instead, we're going to isolate x. So to do that is exactly the same as if we had all numbers. So if we were to have, let's say, like 2x plus 5 equals 7. We would get rid of the constant because that's what's being added to x. And then we would divide by 2 because that is what is being multiplied by x. So the process here is going to work exactly the same. Let's take a look at what's being added to x. So right now, the term by is being added to x. So we want to subtract by away. So now on the left side, I'm just left with a times x. On my right side now, I have c minus by. I can't combine them because they're not like terms. They're different variables despite being raised to the same power. Now, again, I want to isolate x. So now on the left side, I have a times x. So I get rid of multiplication by division. So on the left side, I'm left with x. On the right side, I'm left with c minus by, that whole quantity divided by a. And now x is all by itself on the left side, so it's isolated, so I've solved for x. So what I want you to do now is go ahead and flip to the notes packet for today. We're going to take a look at notes number 1, and we're going to go through solving the odds together. So if you need a second, go ahead, pause this video so that you can then take out your notes packet. So solve each equation for the indicated variable. G equals 6x, 4x. So again, I'm solving for x, which means that's the variable that I want to isolate. So if I look at what's on the same side as x, it's just the 6. And what's happening between the 6 and the x is multiplication. So to get rid of the 6, I need to divide by 6. So now I get g over 6 is equal to x, and x is now isolated. Number 3, I want to solve for a. So on the same side as a, I have a 12 and I have an m. I have 12 times a times m, so I can get rid of the 12 and m by dividing, because division undoes multiplication. So now I'm left with a. On the left side, on the right side, I have 4 over 12m. But 4 over 12 simplifies because 4 goes into both 4 and 12. I'm left with 1 over 3m. Because 4 goes into 12 3 times. Number 5, I want to solve for a. So first thing I do is look to see what's on the same side. So I have a b and I have a negative c. First, you get rid of addition subtraction. Yes, it's true that c is negative, but if you look, what's happening between that negative c and the a is actually multiplication. It's the b that's being added. So I have to get rid of that positive b by subtracting b. So now on my left side, I have g minus b. Because they're not like terms, I can't combine them. On my right side, I am now left with negative c a. So I go ahead and I now want to solve for a. So I have negative c times a. So I get rid of my multiplication by division. So I'm going to divide both sides by negative c. So I'm now left with g minus b all over negative c. And now a is isolated. Okay, number 7, I want to solve for a. Ooh, there's a typo here. Let's see, which one do we want to make a? Let's make it the u equals 3b minus 2a plus 2. All right, so again, I want to isolate a, so I get rid of addition, subtraction first. So I'm going to have to subtract the 3b and subtract the 2 on both sides. So on my left side now, I have u minus 3b minus 2. Again, I cannot combine any of that because none of them are like terms. On my right side now, I'm just left with negative 2a. So I'm going to divide both sides now by negative 2 because it's negative 2 times a. So I get u minus 3b minus 2 all over negative 2 equals a. Now, some of you might see that negative 2 over negative 2 and want to divide that. Now, if you divide that negative 2 by negative 2, you have to divide everything by negative 2. So another way that I could express this answer is negative u over 2 plus 3b over 2, because 2 negatives makes a positive when we're dividing, plus 1. So this is an alternate solution. One of them is not better than the other, but both are equally good. And the reason for literal equations is, 1, understanding the process of solving, but also 2, we're going to be graphing in a couple of days, and being able to solve an equation for y is going to become very important. So the examples on the back side of our notes are going to focus on that, solving an equation for y. So for all of these examples on the back, we want to solve for y, meaning isolate my y. So in this example here, I have 3x plus y, so I need to get rid of that addition by subtraction. So on the left side now, I'm just left with y. On the right side now, I have negative 3x plus 12. I know that my x is negative, but you still want to write it first. You always want to write things in standard form whenever possible. And again, you cannot combine those to get a 9x because they're not like terms. Negative 3 is attached to x, 12 is not. Number 11, I have a 3x minus y equals 16, so I get rid of the positive 3x by subtracting 3x. So I'm left with a negative y equals negative 3x plus 16. And again, mathematicians are lazy, so when you see negative y, what that really means is negative 1 times y. So I'm going to now get rid of the negative 1 times y by dividing everything by negative 1. And this is something that I can actually do. I now have positive 3x minus 16. When you're solving for y, you always want to separate your x and your constant, because again, it's going to help us when we get to graphing. So number 13, I want to solve for y, so I get rid of that minus 5x by adding 5x. So I'm left with negative y, or negative 9y equals 5x plus 23. And now I'm going to divide everything by negative 9. So I'm left with y equals, again, you want to actually separate that. So that gives me a negative 5/9 x and a negative 23rd ninths. On your test, I noticed a lot of you guys did the long division and came out with a decimal for that. That's so unnecessary. Just leave it as an improper fraction. Don't waste time. Don't waste brain cells, possibly making a mistake and getting an answer wrong. Just leave it as an improper fraction. All right? So that's our lesson for today. What I want you to do now is do all of the evens on your own. When you are finished, you can, of course, talk with your partner to check your answers, and then when you're all done, come up and get them checked by me. If you notice that I'm sitting talking to a student, please do not interrupt us. Please wait until our conversation's over, and then you can come up and ask me a question. In the meantime, again, ask your partner a question, ask the people sitting by you a question, try and see if you can get it first that way, and then come up and see me. All right. I hope you enjoyed our lesson, and I will talk to you guys soon.